Okay, hi everyone, I'm Eva. Yeah, I'm talking about Elastic Cloud and Kubernetes, and that's a great thing because on 4 words, there are already 3 of my favorite things in IT, and one's Elastic, and the other one is Cloud, and the other one is Kubernetes. I can't do much with the on, I'm sorry. So that's me. Please don't look at the photograph, it's terrible. Not much to say. I'm in Elastic as senior solution architect since 1 year. Yeah, in the IT world, I'm been for a little more longer. Well, as I mentioned, I like cloud, I like Kubernetes, and I like Elastic, and of course, open source. But let's talk about nice things. As Ramon already said a lot of nice things about containers, so going on with that. I also have a list of passwords of things which are good with containers. Why do we like containers? And yeah, what is the best thing about containers? So for me, the best thing is that you can put it wherever you want, also portability. You can take your containers, you can take your containers application, and you put it wherever you want. So let's put it in the cloud, right? A lot of passwords about the cloud as well. Yeah. But what do I do if I want to put my Elastic cluster in the cloud? And so the fastest way is to go for Elastic Cloud as fully managed service. That's available for the biggest hyperscalers. And if for any reason you don't want to rely on a fully managed service or you can't, then there is an alternative. You can go with Elastic Cloud on Kubernetes as well. So to say, the way is a little bit longer, but yeah, you can enjoy the view and you have a little more control about what is going on behind the scenes. So that's the topics I want to share with you today, starting with Elastic and why do we need to orchestrate that and how do we do that. Then Elastic Cloud and Kubernetes. And then I'm going to show a little example where you see how I'm putting a prototype in the Google Cloud. So I'm sorry, a demo of Elastic Cloud and Kubernetes in the Google Cloud. So starting orchestration Elastic. So that's Elastic. How many of you are familiar with Elastic? Have used it? Good, because I wasn't talk a lot about, I'm not going to talk about a lot about the features, so it's a good thing you're already familiar with that. But yeah, Elastic, what I personally like about Elastic is that it's powerful and the complexity grows with the complexity of your use case, right? But the main thing is quite straightforward. You have your data coming in, you see it on the left side. You can take almost any data source you have. You normalize the data with Elastic schema, and then you put it in Elasticsearch. Elasticsearch is the heart of our solution. It's a distributed free and open search analytics engine, and you can put there as structured and unstructured data. We have also the integrations. That's that's part of the left side, so to say. We have the bits and the agents, and that's what allows us to put the data into the system. And we have Kibana, that is the window to Elastic, and it's also an analytics and a visualization tool. And yeah, we have our 3 solutions based on the Elastic stack, on the same stack. We have the search, we have observability, and we have security, and you have everything there. And on the right side, this is also quite important. It's not only about the data, it's not only about finding the data or analyzing the data, it's about doing something. And yeah, you can define alarms, you can define alerts, you can define actions. When something happens, then you can do something else. You can send notifications, you can wake up your incident response team in the middle of the night or whatever you want. So that's really a simplified view of Elastic architecture. That's only to give you an idea of its distributed nature. You have the agents and you have the bits that are our shippers. over data shippers. Then yeah, you may have Fleet. That's centralized manager of the agents. You might have Logstash if you have data transformations, and you have Elasticsearch for sure, and probably Kibana as well. Inside Elasticsearch, you have nodes, and you have different types of nodes, and yeah, and you can have many of them. Here you already see that even if it's a small cluster, that might be a small cluster, you already have a lot of components. But yeah, no, usually it goes further. You have more use cases, you have maybe more tenants, more teams, you have dev, you have test, you have production. So you have many clusters. At the end, you have the need to orchestrate all of this. So we come to orchestration. And what does come to your mind when you think orchestration? Well, that probably. Okay, that's more a fancy definition, but it's, yeah, the thing is, orchestration at the end is about taking something, some single jobs which are doing something, and put it all together into a whole thing with a goal. And we saw like Kubernetes is the way to do container orchestration. Thanks, Manu, for that. And in a similar way, we want to orchestrate Elastic. And for Elastic orchestration, we have, yeah, of course, the cloud, the Elastic Cloud, but also we have ECK, Elastic Cloud and Kubernetes. That's the one I'm going to talk about. And we have ECE, that's Elastic Cloud Enterprise. So we saw that we have to orchestrate Elastic, and that Elastic is distributed by design. So now we're going to go with Elastic Cloud on Kubernetes. Well, to put Elastic on containers, as I mentioned, you can go to Enterprise, to Elastic Cloud Enterprise, which comes with its own orchestration mechanism. Is also based on containers, but it's not based on Kubernetes, and that's usually, yeah, used on-prem. As not usually, that's used on-prem. In the opposite side, you have Elasticsearch as a service in Elastic Cloud, as a fully managed service. In the middle, you have the Kubernetes way to the things. You can, if you have your own cluster, usually you're going to have your VMs in your environment with the Kubernetes cluster on top of it. You could, if you want, put the VMs on a cloud service, infrastructure as a service, and put a Kubernetes cluster on it. But usually, if you go for a partially managed service, it makes more sense to go for container as a service, being GKE one of them. And then you can put ECK on top of it. So the beauty of Kubernetes is Kubernetes doesn't care if you're on the cloud, if you're on premises, if you're on a Raspberry Pi, or if you're on Google. And yeah, with ECK, you get the operator and you get the custom resource definitions. And with these two things, you can install your Elastic resources as Kubernetes resources. And from these possibilities here, we're going to talk about this one today. So ECK, Elastic Cloud and Kubernetes. I think I said that already. Yeah, Kubernetes brings the cloud native techniques and advantages to both cloud and on-premises environments. And I think that's important because as a cloud for me is not only about where are you hosting your applications or your servers. For me, it's more about the methodology, a way to work, the cloud native paradigm. And so it's the new way to do things, to do software deployment, development, and to deploy applications. There are still customers or companies that for some reason can put their application on the cloud. Then with Kubernetes, you can bring the cloud to the earth, to say so, to your data center on premises. And with ECK, we have the ECK is the Kubernetes way to deploy Elastic. So with ECK, you have a full native Kubernetes experience. You deploy Elastic as any other Kubernetes application with kubectl and the custom resource definitions. You can put it on any Kubernetes distribution. There are multiple Kubernetes distributions which are officially supported. Good. The ECK operator. So before I talk about the operator, I have to take a step back and talk about what is a controller. So the controller in Kubernetes is the one who is watching over the state of your cluster and checking that the current state is the same as the desired state. And if that's not the case, then it triggers an action. So with ECK, what we do, what Elastic does, is to extend the Kubernetes API with the custom resource definitions. So you can manage the Elastic components in the same way as the Kubernetes native resources. And the Elastic components are these ones, Elasticsearch, Kibana, and a couple of them also. So the ECK operator at the end acts as the controller for the Elastic custom resources. So an example, you have the ECK operator, and my desired state is I want to have 3 Elasticsearch nodes and 1 Kibana node. And I don't have anything deployed yet, so the desired state is not the same as the current state. Then what the ECK operator does is it creates a stateful set, and for each stateful set created an Elasticsearch node. This is a pod. And it also creates a replica set, and from this replica set, Kibana instance is deployed. It also creates the certificates, the DLS certificates, and the services which will allow us to access Kibana and Elasticsearch. And it also creates a default Elastic user. So yeah, we saw how Elastic Cloud and Kubernetes is the Kubernetes way to do Elastic. And now, yeah, I'm going to show a small example. And look like this. I have my account at GCP, and I want to put ECK in the Google Kubernetes engine. And what I do is I create a VPC and a subnet. I define a public IP. I create, of course, a Kubernetes cluster. And I define a DNS record, so I can associate my host name with the public IP. And then, of course, I put a node pool on it. And this node pool, we have the Europe West 3 region, and a node is deployed in each zone of that region. And how do I do that? So that's the way I like to do that. It's not the only way. So I could go to the nice GCP UI and click around and create the resources, but I'm more a fan of declarative configuration. So I like to have my cluster, the configuration of my cluster in code in my repository. So anytime I need it, for example, today, I can spin it up quickly, and then it's there. And for that, yeah, I use Terraform. The configuration of the infrastructure will look more or less like this. That's an extract of the TF file. We see here we have the cluster, and we have the node pool, and yeah, the other things as well. You don't see here, but it's the same way. And assuming I already have my files, only thing I have to do, apart of cloning the repository, of course, is to run Terraform init and then apply the configuration. So at the end, that's more or less the only command you have to run, and then you get your Kubernetes your Kubernetes cluster on GKA in a couple of minutes usually. I did that before, so I don't trust my luck to do that live, especially after the Beamer incident. But what I can show you is how it looks like. So I have it running. Yeah, that's my GCP console, and here on the Kubernetes section, I see the node pools and the nodes. Nice, right? So now I have a Kubernetes cluster, but let's put something on it. So let's put Elastic on it. And we do that deploying Elastic as Kubernetes resources. So that's what we had. And we see here we have something new. Okay, it's not that important. That's just the engines ingress controller and the cell manager. I come from the PKI world, so I like when I have a demo to have trusted certificates when you access it over the browser. So for Kubernetes, I like to use Let's Encrypt and the cell manager to issue certificates. You can use the ingress controller of GKA, as I use ingress here. But more interesting is you deploy the ECK operator and the CRDs. So that's the two main components of ECK. And then you can deploy your Elasticsearch resource. You have, I see here in this example, we're going to have 3 Elasticsearch nodes, 3 Elasticsearch pods at the end, and each one of them is going to be deployed on a worker node. So we have the service that comes with Elasticsearch resource as well, and we have a persistent volume claim for each one of the Elasticsearch nodes, and each persistent volume claim comes with instances a persistent volume, which is associated to a solid state disk in the machine where a worker node is running. And we also deploy a Kibana resource, and that also comes with its own service. And for the TLS termination, I do TLS termination in the ingress, but I have also an ingress in order for the application Kibana in this case to be accessible from outside over the service. I also put on there my Elastic agents. The Elastic agents are deployed as a daemon set, so there is an agent for each worker node. And then I put my fleet on there, and fleet to rule them all agents. So as I mentioned, ingress control and cell manager, I use Helm to do that. You can also put it in Terraform, or you can use another way. I installed the custom resource definitions. I did it manually using kubectl for didactic reasons, so I can show the steps here. I directly took the URL from the last available version. I installed the operator, same way. And then I install everything else. With everything else, I mean that I use customize in a customization YAML file to install the cluster issue. That's part of the certificate thing. The ingress, the Elasticsearch, Kibana, fleet, and the agents. So if maybe you're wondering, can I use the customize to install the custom resource definitions and the operator? Yeah, absolutely. You can put everything on there. I just did it so in order to have it separated. So then, with that, we should have ECK up and running. If my cluster is still there, and I will hope so. And here, that's ECK running on the Google Cloud. I guess you're all familiar with the Kibana interface. Yeah, we can go, for example, to Fleet and see if it's working. Yeah, here we have Fleet with the different agents. So that's how it looks. And maybe that's going to be complicated. I can come to this one because I need both hands. It was much easier with Zoom in the COVID time. So I wanted to show quickly. That's my terminal. It's great. I don't have to ask if you see my screen. I think it's safe to assume that you're seeing the same thing that I see, right?
It's a good question. Today is a good question.
You're right. You're right. So let's clear up a little bit. Yeah, I wanted us first to show everything with this running. As we see here the pods, we see here Fleet, we see here Kibana, Elastic agents. A nice thing about the custom resources is okay. I can do Kuzel Kit kubectl get pods, exactly the same I did just now. But I can also do kubectl get Elasticsearch, and then I'm getting my Elasticsearch as a Kubernetes resource, and I'm happy that it's green. Yeah, you can also get Kibana, same thing, and you can see the agents. Okay, and maybe another thing about it, we can get the pods and see where they are running. That's a little bit confusing, sorry about that, but what I wanted to show is that so if you say the names of the pods, so the pods which are deployed through a deployment, like Kibana, have a name which is similar to this. That's the name of the deployant, and then some random ID at the end, right? And Elasticsearch is a little bit different because Elasticsearch is a stateful set. So you see there's a nice name for each pod, and that's always going to be the same name. If I kill the pod and come again, there's going to be the same name. And why is that? Because Elasticsearch needs to be installed as a stateful set, because you want the same pod to be always scheduled in the same node, and that's because of the storage. You want to have the Elasticsearch node accessing always the same storage, which has to be local to the machine where the whole thing is running. It's a little bit complicated because it's a little bit of a contradiction, the whole Kubernetes setup, but that's exactly the way to do that. Good. Yeah, that's actually what I wanted to show here. Yeah, I'm done already. So, you have any questions, or you prefer to do it with a beer?
I have some socks for questions. Maybe that helps.
I have a microphone.
You get a microphone and socks. I'm sure you still have socks from last time.
Eva, you had these free nodes, and one is master node and the others are the ingest node, or how you define it? I didn't see it.
Now in this setup is there's a really a simple setup. So all the nodes are master nodes and data nodes at the same time. So they're so you can assign a role for each node. You can have dedicated nodes for each role, or you can put it together. It depends in the use case you have, and usually on the size of your cluster. So for this example, it's
for the standard installation, free master node and data node.
Yeah,
at the
free
same time.
master node is it's best practice, right? To make sure that you have quorum, so your application is reliable. So even my demo is reliable because I have 3 master nodes and 3 different availability zones. So yeah.
Okay, I hope
Are you using for storage?
So in this case, I'm relying on the default storage class of the GKE, but it's also you can use any Kubernetes compatible storage. So ECK doesn't come with its own storage, but you can use anything the provider offers you.
And you need 3 nodes for Elasticsearch.
You don't.
Have a redundant configuration.
Yes.
And these are mostly, so from my experience, these are the most performant requests in there. So that's why I'm not always happy to have them running on a Kubernetes engine. I more prefer to run them on a bare metal system with fast access to the storage with low latency. But this may depend on the workload you have on there.
Of course, depends on many things, but also I think it's also a matter of price. Maybe you can negotiate with Google, but if you pay enough, you can have really storage, which is really you can access
For the
very
ingest
quickly.
part, I absolutely agree with you. So if you have several logstash configuration and several feeds and so on, it's really happy. I'm really happy to have containers in there and manage that with Kubernetes. But for the Elastic part,
Yeah, so I have to be honest.
Yeah.
Yeah, I don't know, but it's easier if you do it locally, of course.
Yeah, easy.
Hi, thanks for presentation. And I would like to ask the example of free nodes,
Mhm.
gentleman just mentioned. That's kind of static one, right? You define it, it's go up, and it's running. How would you manage if you want to have a dynamic, right? That the whole Elastic cluster
Mhm.
would be dynamic depending on how much storage I need right now, right? How fast our queries are running. Is there also something that is embedded to kind of reflect these requirements? Or that would be something else that I would have to kind of guide the whole cluster to scale up or scale down?
As I'm sorry,
I was asking about autoscaling.
auto scaling.
Yeah.
Yeah, you can. Also,
Thanks. That is much easier.
yeah, so scaling and auto scaling is an inherent feature of Kubernetes. So it's you can do it like that. Also you can scale manually. Also you can say, okay, I have 3 nodes, now I need 5, and you change the configuration, and then you have a rolling update, and that's it. Or you can auto scale. Yeah. Also you have two dimensions with Kubernetes. You have the pods. You can scale the pods horizontally, and then you have the nodes. The nodes that will be the machines on the Google Cloud in this case, and you can also scale those.
I do understand that part,
Mhm.
but how the Elastic itself would kind of guide that, right?
The ECK operator, if it doesn't already, will have auto scaling. Is it released on ECK?
I don't know.
So we already have it on Elastic Cloud auto scaling. So based on disk usage or other metrics, it will scale the Elastic cluster up, and that will be coming to ECK if it's not already there. It might already be there because I haven't checked what the last releases are.
I thought it's there, but
I
saw
thought it was
pull
there as well, but I
requests,
didn't want to lie.
Pull request doesn't mean it's released. So.
Yeah. So there is one thing I'd like to point out as well with ECK, unlike ECE, is that it supports BASIC, which is Elastic way of saying you can use it with the open source version. You don't have to pay for it. I'm going to say that now because I see nobody from our sales teams in this room. So
Thanks for the presentation. I have a question. Can we run this thing in the multi-cloud environment? Multi-cloud.
Multi-cloud, yeah.
Yeah. For example, one node running in Google Cloud and one node, 2 nodes running in.
From the Elastic perspective and even from the Kubernetes perspective, that works. Yeah, it's a little more.
But how do you
challenging.
monitor those things? For example, the health of the nodes. And
Sorry.
how do you monitor the health of the nodes?
You can use Elastic to monitor your infrastructure.
Okay.
But yeah, so I mean, you can do it. It's of course more complex, but you can distribute the cluster.
And what about the failover mechanism? For example, one node is failed. Do you want to build the node on the same cloud, or can we just port this thing into the another cloud? Is it possible?
Sorry, I'm not hearing.
I said, what are the failover mechanism there? For example, failover mechanism.
For Elastic, you mean?
Yeah, for example, the cluster, one of the node which is failed on, suppose Google Cloud. Or
So in this case, if we're talking of the Elasticsearch nodes, when one fails, then you have the operator. Also, no, in that case, you have the controller. And also when a replica is missing, when a pod is missing, then it's going to be automatic. It's going to, a new one is going to be set up. And in the case of Elastic, it's going to be set up in the same node as before.
Thank you very much.
I do have a quick question also with respect to the autoscaler, because especially when you have set up with hot, warm, and cold zones or tiers, will he then also individually autoscale the hot zone in case you see you get much more data than in the past? And then similar then also, of course, for the warm and cold zones, and then move all the shards and so on?
That's a good question. I don't know. I think, yeah, that also depends on the underlying Kubernetes infrastructure. You have to distinguish groups of nodes, right? To say these nodes have, these nodes are going to host the Elasticsearch hot nodes. These nodes are going to host the other ones. I don't know. Someone, Google maybe knows if you can define different autoscaling policies for different groups of nodes. Probably it should be possible, but I don't know honestly. maybe we can talk about it later
One question.
with a beer.
Hello. Hi. So one question about the rolling of upgrades and changing of setup. Is it like a mechanism in the operator that kind of updates settings, setup of the Elastic? And then when you want to upgrade or change version, how does that happen?
How do you update?
Yep.
The operator or the
So if you want to change version on the Elastic or do something that we want to go through all the the nodes.
so
how does that
you can change the
state?
configuration, you can change the manifest. And then you change the manifest, and then the cluster is going to do a rolling update usually, and this is going to update each node progressively as the new nodes are going set up, and then the old ones are going shut down.
Okay. Thank you very much.
Yeah, maybe a difficult to answer question. I was on a Elastic On in November, where I heard a talk about the Elastic stateless mode, where instead of local storage, all the data was stored on S3, and as we have heard, this should be available soon on cloud, on the cloud service. Do you know if there are plans to make that available, like to ECK as well?
No, I don't know.
Because this would solve a lot of problems with static workload.
It sounds good, but honestly, I can
Okay.
I can say.
So we're gonna do last question over there. I run out of socks, so
hi.
that's a physical limitation.
I have plenty of socks. Just a simple question. What happens with quotas when you're auto-scaling both the nodes and the pods within Kubernetes? Do you also have quotas on the pods as well? Thanks.
Yeah, that's a good question. So you have defaults which are defined by the operator, but of course you can set limits and quotas, as the same as you do with any other Kubernetes application. That's possible. That's usually recommended. As I'm not talking only about Elastic right now, but in general, when you have Kubernetes application, it's a good practice to have limits and quotas defined. Yeah.
Great. That is the last part. Thanks again.